Here is a shaded image of the Stanford bunny, which consists of 37,000 vertices. The input mesh is overlaid on the shaded image. As the first step of the approximation, we simplify the input mesh using the QEM technique. We start our approximation algorithm using this QEM simplified mesh as the control vertices of the approximating loop subdivision surface. We iteratively update the positions of the control vertices and insert control vertices in the regions where the errors are large. We can observe that the details of the bunny model are emerging as the iteration proceeds. As the number of iterations increases, the error percentage decreases. This current calculation is in real time, but includes computation of the limit loop subdivision surface for rendering. Without this, the computation can be done in almost half the time. With 22 iterations, the maximum error is less than 0.05% of the bounding box diagonal of the model, and the average error is less than 0.01%. We compare the results by showing the original model and the approximated model alternatively. The blue mesh is the control vertices of the loop subdivision surface, which is shown in gray. The white spheres are the given data points. For each given data, we compute the closest point on the approximating loop subdivision surface. These orange lines represent the error vectors. The red lines emerging from the triangle vertices are displacement vectors for the next iteration. After one iteration, we can observe that the error vectors have decreased drastically. In the fifth iteration, we insert control vertices into the regions where the maximum errors have not decreased. We do this by applying a 1:4 split with crack fixing of the neighboring faces. This armadillo model consists of 173,000 vertices. This is a close-up view of the tail. This mesh consists of 433 vertices, which is only 0.25% of the original mesh. With this coarse initial mesh, the resulting approximation surface includes unwanted undulations. Starting with 1% of the given points, or 1,730 vertices, produces a visually pleasing final surface. After the control vertices are inserted, we apply edge flips to lower the regularity measure. We also apply edge flips to reduce any minimal angles. This is a close-up view of the chest of the armadillo model, which includes elongated triangles. Without edge flips, it ends up with unwanted undulations. But with angle-improving edge flips, such artifacts disappear. Examples of results include the CJA model with 134,000 mesh. The initial mesh consists of 1,343 vertices. The armadillo model consists of 173,000 mesh with 1,730 vertices.